Good day. Today I'm gonna discuss to you the summary of the chapter 11, which is this switch security configuration. The chapter 11 has the parts of the implement for security, the 11.1, 11.2 is the mitigate villain attacks, 11.3 is the mitigate DHCP attacks, 11.4 is the mitigate ARP attacks, 11.5 is the mitigate STP attacks, 11.1 is the implement for security. First, we have the secure unused ports. All switches ports interfaces should be secured before the switch is deployed for production use. Next, we also have the VLAN attacks review. Here, as a quick review, a VLAN hopping attack can be launched in one of three ways. First is the spoofing DTP messages from the attacking host to cause the switch to enter trunking mode. From here, the attacker can send traffic tag with the target VLAN and the switch then delivers the packets to the destination. Next is the introducing a rogue switch and enabling tracking. The attacker can then access all the VLANs on the victim switch from the rogue switch. Another type of VLAN hopping attack is a double tagging or double encapsulated attack. This attack takes advantage of the way hardware on most switches operate. And we also have the DHCP attack in review. The goal of a DHCP starvation attack is to create denial of service. DHCP starvation attacks require an attack tool such as Gobbler. Recall that DHCP starvation attacks can be effectively mitigated by using port security because Gobbler uses a unique source MAC address for each DHCP request sent. And however, mitigating the DHCP spoofing attacks requires more protection. Gobbler could be configured to use the actual interface MAC address as the source Ethernet address, but specify a different Ethernet address in the DHCP payload. This would render port security ineffective, and because the source MAC address would be legitimate, and DHCP spoofing attacks can be mitigated by using DHCP snooping on trusted ports also. The dynamic ARP inspection. In a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. Prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are delayed. This is the mitigation of MAC address table attacks. The simplest and most effective method to prevent MAC address table overflow attacks is to enable port security. And next is the enable port security. We have the again the limit and learn MAC addresses, and in the limit and learn MAC addresses, the switch can be configured to learn about MAC addresses on a secure port in one of three ways. First is the manually configured. Next is the dynamically learned. Third is the dynamic learned sticky. First is the manually configured. The administrator manually configures a static MAC addresses or address by using the following command for each secure MAC address on the port. The dynamic learned is when the switch port security command is entered, the current source MAC address for the device connected to the port is is automatically secured but is not added to the startup configuration. If the switch is rebooted, the port will have to relearn the devices and MAC address. Lastly is the dynamically learn sticky. The administrator can enable the switch to dynamically learn the MAC address and stick them to the run configuration. Next, we have in chapter 11 we have also the port security aging, which can be used to set the aging time for static or dynamic secure addresses on a port. And there has two types of aging that are supported per port. First is the absolute, and second is the inactivity. Absolute is it secure the addresses on the port are deleted after the specified aging time. In inactivity, the secure addresses on the port are deleted only if they are inactive for the specified aging time. Next, we have the port security violation modes and the port in error disabled state. In port in error disabled state, a port is shut down and placed in the error disabled state. No traffic is sent or received on that port. A series of port security related messages display on the console. Next is we have the verify port security. In here, after configuring port security on a switch, check each interface to verify that the port security is set correctly. Next we have the 11.2, which is the mitigate villain attacks. And in mitigate villain attacks, we have the steps to mitigate of villain hacking attacks. And we also have the syntax. Yeah. And 11.3, which is the mitigate DHCP attacks. And we have the first the DHCP attack review. And the goal of it the DHCP starvation attack is to create a denial of service or DOS for connecting clients. Next, we have the DHCP snooping. Snooping does not rely on source MAC addresses. Instead, DHCP snooping determines whether the DHCP messages are from an administratively configured trusted or untrusted source. And next is the steps on implementing the DHCP snooping. We have our first step. We have to enable the DHCP by using the IP DHCP snooping. Step 2 is to use the IP DHCP snooping trust command. Step 3 is to limit the number of DHCP discovery messages by using the IP DHCP snooping limit rate interface configuration command. Lastly, the last step is the step 4, which is the enable DHCP snooping by VLAN by using the IP DHCP snooping VLAN global configuration command. And we have the 11.4, which is the mitigate ARP attacks, which the ARP means address resolution protocol. We have first the dynamic ARP inspection. In here, it requires DHCP snooping and helps prevent ARP attacks by here are some recommended things to do. First is not relying invalid or gratuitous ARP replies out to other ports in the same VLAN. Next is the intercepting all ARP requests and replies on trusted ports. Verifying each intercepted packet for a valid IP to MAC binding. Next is the dropping and lagging ARP replies coming from invalid to prevent ARP poisoning. Last is the error disabling the interface if the configured DAI number of ARP packets is exceeded. And we have our DAI implementation guidelines. To mitigate the chances of ARP spoofing and ARP poisoning, follow this DAI implementation guidelines. Here first we have the enable DHCP snooping globally. Next is enable DHCP snooping on selected VLANs, enable DAI on selected VLANs, configure trusted interface for DHCP snooping and ARP inspection. Next we have the We have the DAI configuration, and la and next is the mitigate STP attacks, or which STP means spanning tree protocol. We have here the port fast and BPDU guard. Configure port fast. Next is configure BPDU guard bridge protocol data unit. I think that's all in the chapter 11 summary.